first thing this problem asks us to do is find the interval of convergence for f. So this is my function f I'm looking at. Notice they're giving us a general term. This is not a geometric, so if they ask for interval convergence, I have to use my ratio test here. So set up my ratio test, the limit, make sure we have the absolute value bars, n plus first term divided by the nth term. So this is my setup of the ratio test. This -1, you can take the absolute value of it. It's going to just become 1. I'm going to do a little simplifying first before I take the limit. This x to the n plus 1 over the x to the n will just leave you with an x on the top. All the pieces that have n's in it, the 2n plus 1, n plus 1, I can't simplify anything yet with it, so I'm going to just leave it as is. But then now when I take the limit, notice the degree on the top and the bottom is the same, 2n squared over 2n squared. So ratio of the lead coefficient is 1, so this limit is absolute value of x. Ratio test says it only converges if that is less than 1. So this is the inequality I'm trying to solve, and I can solve this to be this. Okay, now it is asking for the interval, so you need to check the endpoints. So let's start with x equals 1. And I'm going to plug this back into here. So I'm going to plug in 1 in for x. But if I plug in 1 for x, you just have 1 to the n, which is just really always 1. So all you're left with is this. So now we have to figure out what test we're going to use. I'm going to use my alternating series test. And right away, I notice this limit is not going to be 0, so it's actually going to diverge. So you're going to say it diverges by alternating series test. You can tell me it's because the limit is not 0. So this limit is actually 1/2, which is not 0. Or you can tell me in words the absolute value of the numbers are not approaching 0. So either one is fine. Let's do the same thing with -1. Okay? So I'm going to go back to here and I'm going to plug in -1 for x. So let's write the whole thing. Okay. Now, if I do this, -1 to the n, -1 to the n, you can add exponents, so this is really -1 to the 2n, which is always 1, so this really is this. I can use the nth term test. This limit is 1/2, which is not 0, so you would say diverges by the nth term test. This is not an alternating series, but the reasoning is the same for why it diverges. So your interval of convergence would really be just from -1 to 1, not including either endpoint. Okay, the second question says you have a graph, a different function y, but it's basically f of x minus g of x squared. And it gives you one point on the graph, 0, 5, and it's talking about relative max, min, etc. Now remember we talked about this before. Since you don't actually have the actual function, we just have the series, we're not going to be using a sign chart. Okay? But anytime they ask about relative max, relative mins, your conditions are the same. First thing you should always be checking is it true that your derivative is equal to 0? Because if it's not, there's no possibility of a max or min. So first thing I'm going to do is, here's my function, I'm just going to rewrite it. I'm going to go ahead and see what happens at the first derivative. So y prime is going to be bring down the 2, reduce the power by 1, and then don't forget chain rule of all of this, so it's going to be f prime of x minus g prime of x. So this is my first derivative. And I want to know what happens at x equals 0. So I'm going to plug in 0 in for x. So I need to figure out what happens at 0. So if I do that, let's see. I'm just going to plug in 0 for x. Now all of these values, f of 0 is -1, g of 0 is 3. F prime of 0 is -1/2, g prime of 0 is here, -3 over 3 factorial, which is -1/2. So all those values I can go ahead and plug in, and if you do that, this is what I end up with. I believe this is -1 minus 3, and then this is -1/2 minus a -3 over 3 factorial. And if you simplify all this, do the arithmetic, this is 0. So yes, there is a possibility of relative max or min. If this was not 0, you would say neither. There's no horizontal tangent, so there's no possibility of relative max or min. Now this is where we're going to use our second derivative test. Again, I cannot do a sign chart because I don't have the actual function itself. So we have our first derivative. I'm going to go ahead and come up with the second derivative. Notice you will have to use the product rule here. So my second derivative is, I'm going to just leave the 2 in the front. I'm going to think of this whole thing as one term. So we have the derivative of the first, which is f prime of x minus g prime of x times the second, but then notice the second is exactly the same as this, so you really have 2 of those, plus the derivative of this piece, derivative of the second, is f double prime of x minus g double prime of x times the entire first factor, which is all of this. So 2 times f of x minus g of x. Okay? Now, again, the same thing we did here, we can find all of these values from these series that this series they are giving us. So I'm going to plug in all my values. Now this piece here, we just figured out up here what this is. This actually is 0. So I don't have to calculate that again, and 0 squared is 0. Now all of this, okay, it really is not important what that actual value is. You can calculate the numbers if you want. I believe these are the numbers. But you don't actually have to do all the arithmetic. All I know is that this is a negative number. So you have a place where the first derivative is 0, sine of the second derivative is negative, which means that the graph is concave down. So that means that you have a relative max.